Hello, everyone. I'm Ely, and I'm here from Bloomberg with my teammates Balaji and Shruti to talk to you about upgrading your dependencies on open source Jupyter projects. We are all on the IDE team for Bloomberg's bQuant analytics platform. Our users build and share advanced financial analysis applications using Bloomberg data in a hosted Jupyter Lab-based interface. bQuant has been in development for over a decade, and many notable Jupyter maintainers have contributed over the years. Since 2023, the three of us have led major upgrades to bQuant's dependencies on Lab, Widgets, Voila, and Server. As you can see on this slide, our definition of a major upgrade doesn't always mean bumping to a new major version of a library. Depending on the code sins that you or your predecessors have had to commit, a patch bump might be enough to qualify. bQuant was originally built for IPython notebook compatibility, and over the years has depended on every major version of Jupyter Lab. Parts of our code base are a study in past best practices and legacy workarounds that made sense when they were added. The upgrades listed on this slide typically took months from start to finish. Each of these upgrades required collaboration with many internal and external stakeholders. Tens of thousands of financial professionals who use bQuant have benefited from our upgrade efforts. Each upgrade's rollout has gone smoother than the last. Today, we want to share the approach that we've developed as a team and lessons we've learned along the way. There are many solid reasons why we put off dependency upgrades. Take a few minutes to think about reasons why you've held off on an upgrade. After I get through our list, I'll ask you all for any that we missed. Sometimes it's reasonable to skip an upgrade because the changes it brings aren't substantial enough or relevant enough to matter to your users or your code base. It can be hard to estimate how much work will be needed to complete an upgrade before you begin. You may be blocked while waiting on an upstream fix to a known backwards incompatibility. Not all breaking changes get found before they're released to users. Your other open source dependencies, such as third-party extensions, may not be compatible yet. Upgrades take time away from other tasks. Often, those other tasks are more enticing to the folks who decide how we allocate our time. Would anyone like to share any reasons for hesitating that aren't up on the screen? Yes. Increased risk of supply chain attacks. Can you say a little more? Mm-hmm.
You run code that you don't know, essentially, and they could do whatever.
Cool. So sort of new code opens you up to new risks?
Oh, yeah.
Yeah.
I mean, security risks in particular.
Mm-hmm. Yes, back there.
We support faculty in our institution, and sometimes they just don't want to change what they've been doing.
Yeah, users who are resistant to change. That's a good one. Yes. Yeah, like cascading dependency conflicts.
Some of them are on core packages, so it changes core package dependencies and it breaks the image.
Totally. Yes.
One of the things we run into with a mixed environment of technical and non-technical users is just lack of skill from the technical or from the non-technical side, where they don't even understand how the process works.
Okay, so like new challenges to non-technical users being introduced?
Someone will hand them a notebook and a dependency stack, and that version of Python may go end of life, and they don't even know where to start to run an update.
Okay, totally. Did everyone hear that? Okay, cool. All right. Despite the many good reasons to hesitate, we recommend tackling major upgrades as early as you reasonably can. Take some time to think about your reasons for coming to this talk. Why do we bother upgrading? Why not put it off till the last possible moment? Totally, yeah. I'll jump through our reasons and then collect any more from the crowd that we didn't get. So here are our most persuasive reasons for upgrading early and often. Of course, we want to provide our users with the latest features and bug fixes. It's extremely important to stay up to date on security patches, so double-edged sword there. Often we need to upgrade one library as a prerequisite for upgrading another library that our users care about. We prefer to avoid scrambling during end-of-life deadlines. And starting upgrades earlier than necessary means that if you discover a bug that must be fixed upstream, you'll have a cushion of time to report it and wait for the fix. Upgrading unblocks our wonderful maintainers to focus on the future of Jupyter rather than spending their valuable time on supporting past versions. Waiting too long to upgrade usually means taking on a larger, riskier migration, even when you eventually have no choice. Regularly updating to the latest release minimizes the difficulty of each upgrade and keeps our team experienced in the overall upgrade process. We've found that small, regular upgrades are cumulatively less time-consuming and disruptive than infrequent overhauls. Are there any other reasons to upgrade early and often that y'all would like to shout out? Yes?
Sometimes it's easier to make upstream fixes than fixes on your own code.
Totally.
You have to put a PR to against open source, and then after it landed, you have to, after it release a new thing, you have to upgrade to that version to get your fix.
Totally, totally. Sometimes contributing upstream is actually easier than making the change locally. Anyone else? Okay, great.
So once you've got buy-in and it's time to plan for an upgrade, start by defining the scope of the work. Identify which code bases depend on the package you're upgrading. When upgrading libraries, the blast radius may often extend beyond your repos into other extensions, config files, server patches, internal packages, or sometimes even front-end overrides. Look for unused libraries or customizations that could be deleted instead of updating them. Lean on upgrade guides and release notes provided by upstream maintainers and open source contributors to identify backwards incompatible changes that are likely to require special attention as you're upgrading stuff. If you have hacky customizations, forked code, monkey patches, or anything that sounds like this, identify which one of these could be broken by any changes to upstream internals. Other environment updates could be a prerequisite for upgrades. For example, updating versions of Yarn or Node.js, which in turn may affect other functionality. So it would be a good idea to dedicate time to identify the extent of changes required for your upgrade. When preparing for an upgrade, it's important to identify stakeholders as early as possible. Ownership of the code may not always be obvious. You might find code that hasn't been touched since the last upgrade, or abandoned components that could also be poorly documented. If nobody's actively maintaining the code, you might have to figure out the new owner, and sometimes it could be you. I'm sorry if it ends up being you. Identify who's responsible for user-facing communications, such as release notes, announcements, or documentation updates. Identify users who can do hands-on testing before release. As you upgrade, you may encounter conflicting timelines, roadmap impacts, performance regressions, and other circumstances where priorities do not align among various stakeholders. So it's important to be clear before you begin on who has ultimate authority to make these difficult decisions when they do arise. This helps resolve blockers quickly and avoids confusion during crunch time. Lastly, burnout risk is real, especially when upgrades are long and multi-phase. If possible, don't let them always fall on the same person. Once stakeholders are identified, it's important that they don't hear about the upgrade for the first time when things break. Start early with an announcement that an upgrade is coming, why it's needed, and a rough timeline. You could hold kickoff meetings to clarify goals, communicate timelines, and ensure alignment. Large upgrades are often a shared effort, so bring affected teams together early on to assign owners for key tasks. Once the upgrade's in motion, people will need visibility. Use collaborative docs to track things like impacted dependencies, priorities, owners, blockers, and due dates, making it easy to share progress in a transparent way. Periodic status updates help prevent surprises and show steady progress. As a first step, it's useful to remove any dead code so there's less to upgrade. This is also a good time to clean up any unused dependencies and features that may have since been contributed upstream. Revisit old workarounds and see if you still need them. However, it's important to note that while refactoring can simplify an upgrade, any complex refactoring can add risk to the rollout. Upgrading often requires digging into dusty corners of the code base, and you'll likely discover forgotten to-do items that feel relevant to address as part of your upgrade effort. This is usually scope creep. Sometimes it will make sense to include these tasks in the upgrade, but whenever possible, we recommend either shipping such changes before the upgrade or deferring them with proper documentation to reduce rollout risk to the upgrade itself.
There are a lot of great resources to help with fixing issues encountered while upgrading. Treat migration guides as a checklist of breaking changes with tips for fixing them. Release notes give a more comprehensive summary of the changes than the migration guides. Search issues to see if other users have reported the same problem and what solutions have been suggested. When all else fails, open a new issue or ask questions on Discourse or Zulip. Our team is especially lucky to have direct access to the experts at QuantStack for support when we run into challenges. If you have access to consultants knowledgeable in this space, this can be a great channel to accelerate your upgrade work. Note that not every issue you find during an upgrade will be worth fixing. Sometimes the best solution is to ask your end users to adapt. As you discover them, compile a list of breaking changes along with their solutions and workarounds. These can be shared with your users at release time. Before release, be sure to do copious testing. Unit tests may pass, but APIs can change subtly without throwing errors. Interfaces may technically still exist, but their behavior may have changed, silently breaking your users' workflows. Developers think in terms of code. Users care about flows and habits. Early user feedback can surface issues like shortcut regressions, missing menus, or widget crashes. Test across different configurations. Screen sizes, operating systems, browsers, and kernels can affect rendering or behavior. Look out for small UI changes that may or may not be obvious, especially if you have customizations around UI behavior. Icons can go missing, and everything seems to break scrolling behavior. Upstream style changes or class renames can easily break themes and CSS targeting. If you're lucky enough to have visual regression tests, pay special attention when updating reference images in response to expected UI changes. Some new features introduced by the upgrade might require opt-in. They may be disabled by default or require special configuration, or you may want to disable them. As we've mentioned before, the upgrade guides and release notes are helpful for finding out what new features are available and how to enable or disable them. Even when the changes have been thoroughly tested, things may not go as expected. Some issues may surface only with specific workflows. If possible, avoid including any unrelated changes in the upgrade release. Otherwise, every investigation into a reported issue will start with the question, is this caused by the upgrade? Have a rollback strategy in place before the changes are released. Get stakeholder sign-off on the rollback strategy so they know what to expect in the event of a rollback. Some regressions may not be worth fixing. For example, if fixing an issue would significantly delay release, but there is a reasonable workaround and only a few users are affected. Document the issue and the workaround so users can resolve their issue quickly. Prepare yourself for users' sometimes intense responses when they realize they will have to need to adapt to change. The far-reaching impacts of major upgrades mean that these releases often include a long tail of follow-up work. Set this expectation for yourself and your stakeholders. Don't relax too soon. When the dust finally does settle, do make sure to celebrate your success. Every smooth upgrade is a feather in your cap, and every bumpy upgrade is an upgrade you'll never have to do again.
Happy upgrading. And while we have your attention, want you to know that there are still a few spots available for the Jupyter Open Studio Day that we're hosting in our San Francisco office this coming Monday. Much like the sprints on Thursday, this event is a chance for everyone from first-time contributors to seasoned maintainers to come together and work on anything and everything. Please come find me, talk to me, or Ely if you have any questions on this. Thanks.